All right, our next Chapter 6 topic is going to be triangle area. There we go. And what we're going to do is look at a couple different options that we can use in addition to the traditional 1/2 base times height. Well, for the first example, I am going to go with 1/2 base times height, and then we'll generalize it to a pretty useful formula. So, if we want to use the area of a triangle equals 1/2 base times height, we need to know the length of one of the sides in order to be the base, and then the perpendicular distance from that base to the opposite vertex. So, as this triangle is drawn on the page, the most obvious base to use would be this 12, but in order to use that 12, we would need to know this height. Well, one convenient thing is when we draw in that height, we break that triangle that's not necessarily right up into two right triangles. So SOHCAHTOA trig is now fair game. So what we're going to do is a half stays a half. The base is 12. We're going to use some SOHCAHTOA trig in order to get the height. Well, if we look at this triangle that's on the left-hand side, in relation to that 55, that's the opposite, that's the hypotenuse. So the sine of 55 is equal to h over 10. Or in other words, h is equal to 10 times the sine of 55. So 1/2 base times height. There's the 1/2, there's the base we're going to use, there's the perpendicular distance. So 0.5 times 12 times 10 times sine of 55, and we get the area to be 49.15, and we don't have like meters or feet or anything like that. We're just going to use the generic u squared for u. And I suppose one thing I should have done before I did that is check to make sure I'm in degree mode. Yes, I am. So that seems pretty good. All right, let's generalize this into a set of formulas that appears in your textbook. So we were given two sides and you include an angle. So that's a side angle side scenario. So let's call this side angle A. Call this B, C, A, B, C, like this. We knew angle A, we knew angle C, we knew angle B. I'm sorry, that's side C, side B. All right, so what we're going to do is go through the same set of steps we just did with the numerical example, except we are going to do it with the generic letters instead. So we're starting with A is equal to 1/2 base times height. And that A is referring to area as opposed to angle A here. Okay, these are our givens. We don't know this, so we'll actually cross that out since it's not relevant to our formula. I'm going to drop in a height. So coincidentally enough, the base of the triangle is side B on the triangle. And then the height is going to be this guy right here, which we're going to get from a SOHCAHTOA trig equation working on the left right triangle. So the sine of A is equal to h over c, where h is equal to c sine A. Okay, now if I wanted to, I could take this triangle, tip it on one of its sides, one of its other sides, go through the same set of steps, take that triangle, tip it on the third side that hadn't been addressed yet, go through the same set of steps, and we get the three versions of the formula as they appear in your textbook. So the other two versions are 1/2 AC sine B, and A is equal to 1/2 AB sine C. And these are our triangle area formulas. For side angle side triangles. I didn't realize we snuck off the bottom of the page a little bit there. All right, so to recap what we're looking at today, we are examining some formulas in addition to 1/2 base times height. 1/2 base times height is still valid. You can use it as long as you're given, or you can figure out the relevant measurements. A direct byproduct of 1/2 base times height are the three formulas in order to, or the three formulas to solve a side angle side triangle. Okay, second scenario, we want to find the area of a side triangle. Well, anytime we're given side, one quick check you always want to give it is to make sure, well, is this a valid triangle? In any triangle, the two smaller sides have to add up to be bigger than the third side. So the 4 plus the 5 is more than the 6. So it is a triangle. If the 4 plus the 5 is not greater than the 6, then it's undefined. There is no area to a triangle that doesn't exist. So it only takes a couple seconds. It's worth that check. It's the same one we gave when we were using law of cosines. All right, now on to the formula that we're ultimately going to be getting to. All right, now based on what we know so far, if we were to solve this just on the results of this page, we know that if we could get the measure of this angle, we could finish the problem up the same as on the other page. So what would it take to find the measure of that angle? Well, one thing that we learned is if you have the lengths of the three sides, you can use law of cosines in order to get that angle. So one approach that we could take is we could use law of cosines to get angle A. Then once we know angle A, we can treat it the exact same way we did on this other page. Okay, well, law of cosines is rather labor intensive, and we would prefer not to use it unless we have to. Not only that, that's not even the final answer. We'd have to take that and then do more. So it turns out there's another option. Okay, there's a formula, depending on the book that you go to or the website that you visit. It's either called Hero's or Heron's formula. Okay, the derivation for why this works is a little bit on the ickier side. It is in your textbook. I don't recall the page offhand, or you can Google it for the derivation of this formula. It's a little bit above and beyond what we want to do at this particular point in the class. All right, the A stands for the area of the triangle. S is the semi-perimeter. A, B, C are the lengths of the three sides. So the semi-perimeter means half the perimeter, or add up the three sides and divide by 2. So this kind of just becomes a little bit of a plug and chug formula. There's not a whole lot of different variation that we're going to be looking at here. So as far as the perimeter goes, it's 4 plus 5 plus 6. The perimeter of this is 15. That makes the semi-perimeter 15 over 2, or 7.5. So now, just plugging that into the formula, we have 7.5 for the S, and 7.5 minus the A, 7.5 minus the B, 7.5 minus the C. All right, now it comes down to how comfortable you are typing this in the calculator and also considering whether you want an exact answer or a decimal approximation. I usually like to clean this up a little bit. So it'll be 7.5 times 1.5 times 2.5 times 3.5. Now that's rather a messy little number on the inside, that 98.4375. Chances are a question like this, with that type of result, you wouldn't be asked to write it in simplest radical form. If that was like root 200 or something nice and clean that you could write like as a 10 root 2 or something like that, then it would probably be fair game in order to be asked to write that in an exact radical form or a reduced exact radical form. Something like this, it's probably going to be a decimal approximation. So we're looking at about 9.92 square units for the area. Now, due to the unique circumstances that we've discussed many times in this class of our COVID environment, for the most part, the quizzes and tests that we have are going to be either open book, open note if you're taking it at home, or you'll be given some kind of reference sheet to take it in class. So it's not really much of a necessity in terms of what formula should I memorize and which ones should not. But to address it, typically under non-COVID situations, there would be an assessment of this type that would require you to memorize formulas. So let's look and see what's worth it and what's not. For this first set of formulas that we worked off of, even if you didn't memorize these, it's a direct byproduct of just knowing 1/2 base times height and some SOHCAHTOA trig. So my personal opinion would be, if I was studying for a quiz or test to contain this material, I would not consider it to be worth my while to memorize these three guys. I know 1/2 base times height since like the 4th grade. I know SOHCAHTOA trig for quite a while now. It's not a necessity to worry about these. I can develop these on the spot. Now, on the other hand, for this particular problem, if you didn't know that formula, you'd be doing the log cosines followed by either one of those sine formulas or SOHCAHTOA trig in combination with 1/2 base times height. This is one that's a significant time saver. This is one that's worth knowing. It's definitely in your interest in terms of being an efficient trig problem solver to know this formula. All right, that pretty much covers what we're going to be doing today as far as new stuff. The only type of problem left in Chapter 6 is going to be some word problem stuff. You've had a sprinkling of word problems in the homework over the last couple of nights. I think there's 1 or 2 in tonight's homework, and there'll be 1 or 2 on tomorrow's assignment as well. But as far as formulas and how to use them, this wraps up the formulas for Chapter 6. So we covered law of sines, law of cosines, and then some triangle area formulas.